This section, we're moving on, ladies. We'll come back if we have time. This section should remind you of when we started differential equations, except the equations are going to be a little bit more involved. If you look back at our 7 ones that I gave you that you needed to solve, they were already separated. These are equations that you're going to have to probably separate them. They're separable. Okay? I already did that for you in 7-1. Okay, so here's a slope field. Notice the scale, and the scale is going to switch on you, so you can't get like too weird about it because you can control that. The axes currently aren't on here because they would cover up things sometimes. So don't get weirded out if the axes aren't there because, again, there's a reason they're not there. Okay, you have a dot right here, which is at -1, 1. I want you to draw the solution curve, like we've been doing. I'm going to come around and look at it. All right, looks good. Yeah, you're good. Yeah, it's good. It's good. If you got a good, that's good, Megan. Yep.
It looks like a what?
Yep, that looks good, girl.
Oh, it was wrong.
Okay, very good. I'm seeing everything. So you got it. It looks like this-ish, and then probably something like this, right? Okay? So that's the solution curve. Now, what we're going to do in this section is, instead of just leaving it that, we're now going to try to solve this. Solve it, and then you're going to be amazed how close you are to the solution. Okay? So what? It's just an axis, but the axis is blank. It's just showing you where 0 is, but there's no slope where y equals 0. Good points. That's your vertical asymptote right there.
Should we just put an open circle?
So you're good. You crossed it. There's a vertical asymptote. A vertical tangent there. All right. Okay, so this is how we do the separable differential equations. We are going to do plenty. Okay. Remember, your slope sometimes comes with y prime. You don't want y prime, you want dy dx, okay? Because you can't separate it if it's y prime. You can separate it as dy dx. And you've kind of done some separation when you did use substitution already. So you'll recognize that. Then we're going to separate our x's from our y's, okay? And then we should have our y's and then our dy's equal to our x's and then our dx's, whatever that entails here. That's what that's going to look like once it's separated. Then, of course, you have a dy on one side, you're going to integrate that side. You have a dx, you're going to integrate that. Then you're going to have a general solution, and then you're going to find the solution. Okay. So here we go. Let's see. Write the equation in terms of differential. Done. All right. Separate x's and y's. How might you separate them? Cross multiply. I'm going to write my y's over here because I like my y's over here. Because y equals is what I like to look at. But it won't matter. Okay? So that's cross multiply. All right. Right now, our x's and y's are already separated, right? So the next bullet is done as well. We wrote it, we separated it, now we're ready to integrate. Here we go. Integrate, integrate. Okay. When you integrate y squared in terms of y, Kinsey, what do you get?
Y third over 3.
Very good. And what do you get when you integrate x squared, Jenna? Okay. Is there anything missing in this integration? A c. Now, we're not going to put a c on both sides because then your c's will cancel each other out. We're going to write the c with the independent variable.
You said that last time, but I don't understand what that means. Like, how would you know if the y was the variable?
It would look like this. Y is the independent, independent. I want to say X, but it's not always going to be X, okay? So you want to write it with the bottom one, because that's the one that's independent, okay? All right, so don't put them on both sides, because then you'll be like, wait, why do I have C's on both sides? Okay, now, what does it say solve for Y? Alrighty then, what would be the first step in solving for Y, Kathleen? Sounds good. Now, this is the part that's, what's 3 times a constant? A constant. Okay. 3 times a constant is still a constant, right? Okay. All right. Now, solve that last step. Hannah requires what? We're going to solve for Y. We got Y cubed.
We're gonna take everything to the 1/3.
Okay. Or cube root. Yes. All right. Now, remember the algebra rule, whatever we do unto the side. So this time the C has to be under the cube root. This is not the same thing, so please don't do that. Okay, this is called our general solution. I usually put a box around it because I'm going to come back to it after I find my specific solution. But that piece, we did that like from here down already. Remember that piece from 7-1? Mm-hmm. We just didn't go from there to there. So that's the only difference. All right. Our specific solution is -1, 1. So we're going to find our C by plugging in -1, 1. So Y equals cube root of -1 cubed plus C, and Y is what? 1. Okay. So you're trying to find C. What's the first thing you're going to do? All right. -1 plus C. Next, what am I going to do, Emma Sternberg?
I don't know, because you can't do the root of it. Oh, the cube root of -1 is.
I can't do that.
Then I don't.
I got to get rid of the cube root.
Oh, cube side. Sorry.
Cube each side. There you go. Okay, 1 cubed is still 1. The cube root of -1 plus C cubed is? All right. What's C? 2. My specific solution now, I put my 2 in, and I'm done. Okay. Now, pull out your calculator and put that in your calculator. Just on a regular 10 to 10
On the graph?
graph, yeah. You're going to be amazed how close you came to that look right there. Brackets.
Oh, yeah. Just zoomed in.
Yep. This is, if you want to make it look, it's -3 to 3 on both, if you want to do that, to have it look even better. But it's pretty amazing that dopey little sketch right here can look as good as it looks. Are you all amazed?
I'm amazed.
Cube root, you know how to do that? Math. Cube root is number 4. X cubed. Number 4. It's pretty amazing when you think of, look at that. That's 2.
She goes, what are we amazed about? And I go, oh, we drew the same graph that we just checked on our calculator.
-3, 3. I just don't appreciate it. Alright. There's your graph with the same window. Okay? And there's that vertical tangent that you have, that vertical line right there. where you're supposed to have no tangent, okay?
It's like a what?
That you have a vertical tangent there where you don't have to do it. All right.
Oh,
Okay, we're ready for another one. How about we stop talking again? You are so chatty. All right. Specific solution. Now, I made this slope field. It's not perfect, but it's far apart, but I still think you can graph -1, 2, dy dx equals 2x. It's your.
Are we solving the equation too?
Maybe. I think that's next, yes, but.
Because I just meant because I drew it.
Okay. What does it look like? So I parabola maybe? Which makes sense, right? And you have that knowledge that you think, oh yeah, parabola would have a 2x derivative, x squared plus something. Any guesses about what the plus something might be?
1.
1? It looks like it is 1. Most of you all look like you did something like this. Do you want to do it?
It's pretty easy, yes.
Okay. So let's separate. So what does that entail? Yep. Just like we did when we were doing U substitution. Okay. dy, what's in front of that dy that you can't see? 1. So now, what's next? Integrate. All right. Okay, Emily, what's a 1 dy integrated? Good. And what, Christine, is 2x integrated? Let's see. Thank you, Emma, for reminding her. All right. Let's find the c. We're plugging in. What was that point? -1, 1?
-2, negative.
No, -1, 2. Okay. -1, 2. All right, Emma Sterler, plug them in.
2 equals c.
Y equals. So we go right. Okay. So hopefully that pulls some of that together for you. That's an easy one to look at and say, well, that would make sense. And it's a parabola. Some of them aren't so easy, but you know, hopefully that makes a little sense to you. Let's try some harder ones. Okay. All right. So we're looking for the separation. So go ahead and separate it. Raise your hand when you get separated. And then I'll know. Y to the 1 is 1. Is right. So you have it separated. Okay, that looks good. Start integrating. No. Yeah, print down for it. No. Yes, that's correct. That's correct, but I probably wouldn't write it on the left like that because you might want to scoot it over. Same thing, like put 1 over that and dy to the right. Yeah. Okay, so multiply your dx through here, and you got this. Now this has got to go, so we got to divide it. Now, if I remember correctly, you all got confused when we put the dy right on top, so I would write it like this. Okay? The y minus 1 underneath the dy, but scoot it over so it's 2 pieces. Okay, we are ready to integrate. Should we use U substitution? Yes, we should on the left there. What's U going to be? Y minus 1, so du equals dy, right? Okay. So I can switch out. This becomes 1 over radical u du, right? I'm going to keep going with it. What is that integrated?
Wait, why? Never mind.
What is this called? U, stop with the ln. You all did that on your test. Just because it's down there doesn't make it ln. U to the what? Negative 1/2. Okay. What's the antiderivative of u to the negative 1/2, Kelsey? Over 1/2, which is the same as 2, right? Okay, very good. Now you made up, so we got to put our y minus 1 back in. Okay, did I lose anybody? Just because that's down in the denominator, don't automatically think it's an ln. It's only ln if it's a single thing down there. Radical is not a single thing. Okay. All right, ready to do the right side here. It won't take us long to do the right side. Eminem, can you do the right side for me? Let's see. Good job. Okay, so I'm gonna be ready to solve for y here. Once it's integrated, you're ready to solve for y to get a general solution. Solving for y. Okay. Let's see. What should we do first, Jacqueline? Solving for y. Good plan. Not really. No, you wouldn't have to. That's a good question. Emma asked if we have to divide. No, because c divided by 2 is still a constant. If that algebra bothers you, then do it. It just makes the c a little bit more complex. I get why it might bother you. Okay. Now, 1/2 is what? Square root. So you might want to write that as a square root just because that's the way you're used to seeing things. Now, how do we get y?
Square each side.
Square each side. Remember, that has to be done as a side, so so please include your c in that business. We have y minus 1. And I'm just going to do x squared over 2 plus c squared. And then what am I doing this one? Add it. And then we go to lunch, right? Yeah. All right. That's my general solution. General solution. We need to put in 0.5 for the specific. General. And then we need to get, I believe it's 0.5.
That's Emma. She has more gas than I know.
I guess we should be glad that gas is not there. All right. Okay. Plug it in there, Kelsey. Plug them in, sorry.
5 equals 1 plus 0 plus c.
Now, how are we going to? This is just c squared, right?
With c squared, but we multiply, you don't.
You're right. So what does c equal? Plus or minus 2. So now we have to decide, it won't matter. Well, it will matter. We'll just say it's 2. That's 2. I know. No, c isn't. Yes. We're going for it. There's a lot of work that comes up. Sure.
Right now.
What? Okay, so there's your specific solution. I'll think about that. I'll remember that coming up before. Any questions on? The biggest thing is separating. Let's try another one. Y prime equals xy minus x. Okay. We want dy dx, good, equals xy minus x. Okay, I probably wouldn't, well, this has to go together. Okay, but now we get, how do we get that single y out of there? Divide.
You can take the x's out and make that.
So take the x out, and what's left? There you go. Good job, Megan. Okay, now we can separate the x from the y minus 1. You gotta have multiplication to separate. Okay, so now this y minus 1 gotta come over here as what? Okay. Okay, now here we are at 7, 1. This is where we start integrating. Yep. No, y'all are doing it, so I'm just gonna jump in at the end there. What? Oh. She says in her sweet little voice. You have a good voice. That's a compliment. Not a brassy, sticky voice like mine. All right, what do we get on the left side there, Miss Megan Hopt? Nice. Okay. Anybody not get that? Awesome. Christine, what did you get on the right? Okay, don't forget that C. All right. Now, here comes the interesting part where you have to solve for y. All right. What do we do? We have an ln on one side.
Oh, you can get it.
That's right. How does that e thing work there, Miss?
Oh, do you like, would it be e to the x squared over 2 plus c equals y minus 1?
Very good. That's from log equation to exponential equation. That's a. Yes. So what does this become? K times e to the x squared over 2. Oh gosh. Wait. K is, let me scoot it down, I'll do it step by step. Yeah.
I like to rearrange it so that it's in the order that spells key. Is that okay?
Yep. That's your K. Now, this is positive, right? Right here, e to any power. Okay, so we can drop the absolute values. So y equals, finally.
No, you have to get the one on.
Oh, I don't want that there. Waikiki.
Waikiki. Are you from Waikiki? Because I keep looking at you.
Plus 1, right?
Wait,
What's that called? Oh my god, yeah.
What's this called? General, good. Okay. Now we're going to plug in 0, 3.
Oh, it's the biggest pain in my butt.
All right, Holly, plug it in. Plug them in.
3 equals k e to the nothing. So e to the 0 plus 1.
Okay. What's e to the 0? 1. So what's k? 2. So specific solution k is now 2.
Would it be e to the 2 or just 2?
2. We're putting it in here. If you solve for y, then get c, then you put c back in that solution. That's why I always highlight it or circle that general solution so I know where I'm going back with my k or my c or whatever happens. We don't have to. Once, let me do, okay. This Do what? In a minute, yeah. All right, let's do this one because it has a different twist. I'm just gonna put it on a new page though, because it's. This is the twist that some of my AP students got stumped on the test, so I want to make sure it's not gonna stump y'all. I know, I'm not pasting it. All right. It's giant. Okay, first thing is roll. Okay. Anyway, oh, yeah. Now this was the problem.
Parentheses, can't you divide it?
Yeah. You want to divide the whole thing?
Yeah.
Now here's the problem. A lot of people subtracted 2 and then did this. Why doesn't that work? Sorry. How about add the 4y? Can I do that? Okay, that's the problem. This is one unit, or we can divide it up like we did that last one. You can. All right.
One time that we're not as using in your AP.
What?
The one time that we succeed compared to your AP.
Well, this was a test, so sometimes you don't learn things on tests, you know. Okay, now I'll finish, go ahead and finish it, and I will, revisit. It's not any harder than the last one. And it's just a general solution, so I'll stop it. All right. Here's what I was going to do instead. So I'm going to do that over here just to show you. I think I might have gotten it. Oh, gosh. I'm just having a hard time here. Did you get, you probably got this, right, eventually? Okay, so what'd you do from there? Did anybody get to the end here? What'd you get, Holly?
The final answer?
Yeah.
K, oh, do I have to replace it? No, because it's general. K e to the 2x minus 1 over 2 equals 1. I simplified the parentheses.
Say it again, sorry.
K e to the 2x minus 1 over 2 equals y.
I got this.
K.
I didn't get that. So
You think
let's
it's
work-
2x?
Okay, what'd you do with that negative 1/2? So 1/4, okay. All right. I jumped there. Okay. What'd you do with the negative 1/4?
Oh, that's what I lost, is my negative 1/4.
Okay, so that's what over here? Negative 4x plus c, because the constant times negative 1/4 is still, or times negative 4 is still the constant. Okay, now we do the e thing.
Yeah.
What's the matter, Megan?
Oh, no.
E to the negative 4x plus c equals 2 minus 4y. That is positive. We can drop the absolute values. And then e to the c is your k. Okay,
So the negative 4x.
so what do we have? K e to the negative 4x minus 2 equals negative 4y. So y equals
K e to the negative 4x minus 2 divided by 4.
okay. That's your general solution, and that's done.
I lost my 1/4, that's my problem.
Okay. And then you had a difference.
I lost, it's because I lost 1/4 and I took it out of here.
Okay.
Is that what we're doing on our homework, basically?
Yes. All right, so the answers, are you ready to see the answers on the first?
Yeah.
Are we good with this? This, you might see like this, you separated it out. I mean, there's no need to, but, you know, you might see it like that. Put in a negative 4. This is totally right. And I would certainly leave it like that if you were ever going to find k.
When you do the.
You have, did you lose the negative 1/4, Megan, or Mackenzie?
I got negative 4.
Right here. U equals 2 minus 4y. So what's du? dy. Okay, so then you're going to replace that. Okay. And then that's where that comes from, negative 1/4, 1 over u. Okay. All righty, let's see how we did here.
Say yes, because I love to do that.
Wait. We have more? Oh, gosh. Leave them there, we'll go over them next time.
Oh my god.
It's not X is the, whatever you call it. Yeah.
After the test, and she's like, what do you call it?
All right,
I'll explain it.
what did you get for the first one?
The.
Yes? And the second? Yes?
Oh, dang.
This one?
D.
Yep.
Wait, how did you say it was D or C? C.
And this is C.
Oh, yeah.
Oh, that's what Megan had.
Yeah.
Is this B?
Yeah, let me know if we can get.
Having written wrong on my paper. Oh, I had it written right.
You just told Megan wrong. She just likes to get you Megan. She just likes to use you.
All right, we'll finish